Okay, so the first max-min problem we'll do is number 9 from the homework beginning. I think it's on page 2. It says a rectangular box open at the top with a square base is to have a volume of 4,000 cubic centimeters. What are its dimensions if it uses the least possible material? So basically, first just draw your situation. Oh, that is not a good thing to draw with. But it's too late to go back now. So that's got your basic cube there. Oh, because it's a highlighter there. All right, we got it. And you can just call the base dimensions x. Since this is square, it's going to be x by x, and then you can call your height y since it's a rectangle. So then your expression for the surface area of the box would be the bottom, which right here, the surface area there would be x squared, plus the surface area of one of these sides here would be xy, so times all four sides and not the top because it's open at the top would be a 4xy, and that's your total surface area. Then your expression for volume is just length times width times height, which is x times y, which is x squared y. Now you want to maximize your minimize your surface area, so that's what you're going to end up taking the derivative on. So you want to find one of your, either the width or the height in terms of the other from your expression for volume, because you're looking for the other thing, the maximum or minimum on the other thing. So you know that x squared y is going to equal 4,000. So you can just solve for y there and say y equals 4,000 over x squared. So now you have your y in terms of x. You can call the surface area expression, you can substitute that in. So x squared plus 4x times not y, but 4,000 over x squared. That's a terrible x, sorry. So then you do the math on that, x squared plus 16,000 over x, because that cancels out, and you want to rewrite that with an exponent because it'll be easier to take the derivative on. X squared plus 16,000 x to the negative 1. So then your derivative for surface area, because that's what you want to minimize, would be 2x minus 16,000 x to the negative 2. And then you want to let your derivative on the surface area equal 0, because when it's 0, it's at a minimum or a maximum. So 2x minus 1600 x to the negative 2 equals 0. So 2x equals 16,000, not 100, sorry. X to the negative 2, 2x equals 16,000 over x squared. So x cubed equals 8,000 and x equals 20. And then you go back in, you plug in your x equals 20 into the original expression you got for y. Y equals 4,000 over 20 squared, which is 4,000 over 400, which is 10. So you know that the dimensions that will minimize the material you have to use are x equals 10 units and 20 centimeters, and y equals 10 centimeters. So that's your dimensions. And it says a man is in a boat 4 miles off a straight coast. He wants to reach a point 10 miles down the coast in the least possible time. If he can row 4 miles per hour and run at 5 miles per hour, where should he land the boat? So basically your situation here is you got a stream, and it's 4 miles across, or he's 4 miles across, so technically the stream could be bigger, I guess, but he's here. And this is 4 miles from coast, saying this is your coast. Then alright, I'm just going to draw this out bigger because that's easier. So this is 4, this is where he is, this is the shore. That's 4, and then he wants to reach a point 10 miles down the beach, so this whole thing is 10. We can call this part 10 minus x and this part x. which means that this part here, this triangle, is x squared minus 16, x squared plus 16. Sorry, Pythagorean theorem. That's really messy, but basically this part is the 4 miles off coast. This is the point he wants to reach at the end of this, which is 10 miles down, which means that this part is 10 minus x, this part is x, and this part is x squared, or square root of x squared plus 16. So the time that would take him to if he was just rowing, time, we'll call that time 1, time to row, whatever, TR, would be square root of x squared plus 16 over 4, because that's just distance equals rate times time, so time equals distance over rate. So he wants to go that distance if he was just rowing. T2, which is T running. Oh, I guess we can't use R. But yeah, so that can be T1 running, this can be T2, or that would be rowing. T1 rowing and T2 can be running. So then T2 would be that same distance that he wants to go, but this time, since he'd be rowing across the stream, he's going that distance across the water, that diagonal distance, but he would be running on land right here, this 10 minus x, so the distance for that is 10 minus x over his rate running, which is 5 miles per hour. So then the time together would be T1 plus T2, his time rowing plus his time running, which would be, just rewrite it with exponents, x squared plus 16 to the 1/2 over 4 plus 10 minus x over 5. That's your expression for his time taken to row and run together. So then, since you want to minimize his time, you would take the derivative on that so that you can set it equal to 0. So using your derivative rules, you just derive that. Really super messy, I apologize, but keep going. And then the derivative on that second thing is just 1/5, right? Because it's only a first power of x. So then cleaning that up, you get x over 4 times x squared plus 16 to the 1/2. Moving that into the denominator since the negative exponent, minus 1/5. And let that equal 0 because you want to minimize it. So then multiplying through to get just multiplying that x by the 5 and 1 by 4 times x squared plus 16 to the 1/2 equals 0. So 25 x squared equals 16. So I moved, you see what I did? I moved that term over, and then I squared both sides, just because I'm running out of room. I'm doing things at the same time here. 25x squared equals 16 times x squared plus 16, so 25x squared equals 16x squared plus 256. 9x squared equals 256. And x squared equals 256 over 9, so x is equal to 16 over 9. So that x right here would be the distance, so right here he'd want to land 16 over 9 miles downstream. So he'd want to row. You can plug that back in and find how much time he would row for and how much time he would run for, but it's just asking you to find the distance downstream, so that would be the distance. So another type of problem that we haven't done a lot in the homework, but I asked him about and he said was fair game for the test, was one like this. There were some in the book, in the textbook section, where it was basically like find the point on a given line which is closest to some point. So in this case, it's the point on the line y equals 2/3 x minus 1, which is closest to the point 1, 4. So what you do, the process in this situation, is just sort of, alright, to get a look at what you're looking at, just sort of plot this line. So you have your y-intercept at -1, go to 3 over, looks something like that. That's going to be your line. and then the point 1 comma 4, which is just like right here, say. And you want to find the minimum distance between that point and the line. Okay, so I do want to keep this video short, but one thing that I wanted to cover was this one problem. I don't remember where it is, and I don't have my packet, so it's somewhere in the packet. But it's basically just find the dimensions of the trapezoid of largest area that can be inscribed in a circle with radius equal to 10. So basically you have this situation with a circle and the trapezoid with its lower base as the diameter of the circle. So you can go about and start filling in some information. Since you know the radius is 10, you know each of these sides here is 10. Also, you know that these two radii that you draw in here are 10. And you can call the height of the trapezoid in there, I'm just going to call it h. And you can call this upper base, I'm going to call it 2x. So that you know that each half of that base up there is an x. I'm going to try to keep that as neat as possible. But then you have two little right triangles in there that can help you to determine the area. So you want to maximize the area of the trapezoid. So your expression for area of a trapezoid is area is the average of the bases, or 1/2 base 1 plus base 2 times the height. So in this situation, that translates to area is 1/2 the big base, which is this sort of a the diameter there, sorry. is the big base. So that's, that's 20. And then the upper base, which is 2x, you call that 2x, times the height. And that's equal to 10 plus x, just dividing into 2 there, times the height. And then you can rewrite the height using that little right triangle in there, this one. And you can say that the height is equal to the square root of 100 minus x squared using Pythagorean theorem. So then basically what you're looking at for your area is 10 plus x times 100 minus x squared to the 1/2. And to maximize your area, you want to find the first derivative and set it equal to 0. So the first derivative of this expression using product rule would be derivative of the first 1 times the second, 100 minus x squared to the 1/2, plus derivative of the second, let's see if I can fit that in there. Using chain rule there. And you could kind of clean that up, but it doesn't really matter. So if you just set that equal to 0, I'm sort of running out of space here. But yeah, set that whole thing equal to 0. Sort of simplifying as you go. So that negative exponent, just put that in the denominator. Times 100 minus x squared to the 1/2. This is an exponent, sorry, that does not look like an exponent. And then simplify that. I'm skipping like a lot of steps in here, but I'm basically just showing you the method, and I think you can figure it out from there. Doing the derivative is the easy part. It's just once you get the initial situation down. So dividing out the 2. Sorry, I'm sort of running out of room here. I'm gonna move up here. Factors to x minus 5x plus 10. I'm doing this on the fly, so like if this is wrong, I'm sorry, but I'm pretty sure it's right. So then you would get x is equal to 5 and negative 10, and since it's a physical dimension, you know that it can't be negative, so you can outrule the negative 10. So you know that x is equal to 5, which means that the lower base would be equal to 20, upper base would be equal to 2x, which is 10, and then the height would be equal to, back up here, square root of 100 minus 25, so square root of 75, which is 5 root 3. So down there, those would be your dimensions for a trapezoid with max area that can fit into that circle.